Now, let's say we want to reverse engineer. We want to figure out how to do a chemical synthesis, and it's been strongly implied that you're going to be doing an aldol addition or aldol condensation. So let's start simple with the aldol condensation because it's actually the easiest one to do. Tip off that you had an aldol condensation is that you have a ketone adjacent to a carbon-carbon double bond. So this typically is going to be the symptom or the end product of most of these aldol condensation reactions. So how do we reverse engineer? Well, there's a few things to keep in mind. First of all, this double bond that you formed is formed to whatever the carbonyl compound was in the starting compound that was attacked. The second is that the double bond is also formed by elimination of a hydrogen from both the alpha carbon that was used in one ketone and a hydrogen that was attached to, well, it was basically the alcohol that was formed when you did the original aldol addition reaction. So to predict what ketones or aldehydes were used for these types of reactions, all you have to do for an aldol condensation is just cut that double bond. Now, on the side where you don't have a ketone, you're just going to add your ketone or aldehyde, if this ends up being hydrogen. On the side here where you do have a ketone, you're just going to add two hydrogens. And if you work it back out, we get polymerization, the attack here, and the subsequent elimination will give us back to the starting product. So this is a little bit easier to see in terms of what's going on. To reverse engineer an aldol condensation, cut the double bond. The one that doesn't have a ketone becomes a ketone of the double bond. The one that already has a ketone on it, you add two hydrogens. The only ones that can be kind of hard to see here are the aldol addition reactions because they're not as obvious. So let's say you end up with this complex. How do you know that this was an aldol addition reaction? Well, the thing is that you've got this OH group separated from the ketone by a single carbon. So this single carbon here is going to be your alpha carbon on the starting ketone. Now again, to figure out what the starting products are, you're going to look at the bond between what was originally the alpha carbon on the ketone, and still the alpha carbon here, and whatever your alcohol carbon is. And we're just going to draw a line between the two. Wherever our alcohol is, that's going to become a ketone. Whatever side already has a ketone, we're just going to add a hydrogen to it where we broke the bonds. And that will give us the starting ketone that was used for that part of the reaction. So to kind of summarize, if you've got the way you can tell you had an aldol condensation reaction is that you have an alkene adjacent to a ketone or an aldehyde. All you got to do, draw a line through that double bond, separate the two molecules, add an oxygen double bond to one to create your starting ketone, the other one to add the two hydrogens to see what the alpha carbon was before that aldol elimination. For aldol addition, you're going to look for an alcohol that's two carbons away from an aldehyde or a ketone. You're going to draw a line between what's the alpha carbon of that ketone and the actual alcohol carbon. Draw a line through it. The alcohol is going to become your ketone, and you're going to add a hydrogen back. And that's how you reverse engineer an aldol addition and an aldol condensation.